All right, everybody. Now we get into the fun stuff. IPs. Well, we need to understand what an IPv4 address is. IPv4, it's a logical address, right? There's many types of classes, and we'll get into the classes and all that later on. But we need to understand that an IPv4 address is something that we choose, that we put into the nodes so we can go ahead and network and they can talk to each other. And it's a hierarchy of IP addresses. It's not a flat design, it's a hierarchical. I was trying to avoid using that word because it's very difficult. Hierarchical, forget it, word, scheme they use, right? Instead of a flat scheme. So IPv4 addressing, we know that it's 32 bits long address and that it's separated by, it's separated into 4 different octets separated by decimal. We all know this, but we need to go ahead and put these addresses into our PCs so we can go ahead and communicate with each other. Now we know for networking, and we saw that at the very beginning of the course, in order to communicate with another computer, we need to know the source and destination IP, source and destination MAC address, and you need a port number, obviously, which port you're using to get from one location, whether you're emailing, FTPing, or whatever it is that you're going from one side to the next. So you need those 5 things. But we need to understand IPs. We really do. We need to understand the difference between public and private IP addressing, when to use them, how to subnet them, because we're going to be segmenting later on, and why should we do this? So IP, when somebody comes up to you, hey, what's an IP address? An IP address is a logical address that is used on a network that's assigned to every node on the network. If it's a node that's directly attached to a network. I know some of you are saying, well, not every printer has an IP address. You're right, not every printer does have an IP address if it's plugged in to a particular machine. And then it's that machine that shares the printer that has the IP that everybody gets to. But there are printers there are IP printers, and you can go ahead and search them and map them to your computer, whether you search them through Active Directory, whether you search them throughout the network, however it is. All right. But we need to understand, and we're going to start understanding what is this IPv4 address. And let's go ahead and take a look at it right now. I just decided to create this little small network, and you probably saw it at the very beginning. It's the same thing. We got 2 computers that are plugged into a switch, and in the desktop tab, and if you saw the earlier lessons, you should know how to get in here and put in an IP address, 192.168.1.1. And you see I just tabbed, and it put in the default mask for a Class C address because it already, TCP/IP suite classified it as a Class C address. And this would be 192.168.1.2, desktop tab, IP, 192.168.1.2, tab. We don't need a gateway, we don't need a DNS. I'm just showing you what an IP address looks like. All right, and I'm sure you've seen them before, but just in case, there you go. Go back to the command prompt. You can do an IP config / all, and then you would see, let me open this up for you a little bit more, and you'll see the IP address and subnet mask of the particular computer. And then you ping the other computer, which is 1.2, 192.168.1.2, and lo and behold, we have connectivity. Not such a big deal. Very small network, obviously. Nothing really to think about. It's pretty simple. But hey, there's a lot of things that is going on here. We have full duplex because we have a switch. We have 2 collision domains, which is a good thing, right? We increased the number of collision domains from a hub to a switch. Instead of 1, we have 2. So we have that full duplex going on back and forth. And we're probably running, if we looked at the switch at the actual interface, that we're running 100 megabits per second, category 5 cabling, right? So again, an IP address is a logical address, works at layer 3 of the OSI model that we actually design and we implement in all our nodes that are directly attached to a network. In the next video, what we're going to do, or in the next lesson, what we're going to do is break down the different classes of IP addresses. All right, but the format of the address you need to understand very well. Now, one of the things that I do want to do, and I know I did it in other videos, and I want to make sure that I do it in this one, or in this lesson. I keep saying videos. When you're looking at an IP address and you say 192.168, whoops, not 268, 168.1.1. It's very simple just to look at it. Okay, so there's decimal numbers separated by a decimal, right? We have whole numbers separated by a decimal. But what you're really looking at is 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. The computer is not looking at the number 192. The computer sees 192 as that. It sees it in its binary format. You need to really understand that this is what you're looking at right here. All right, because in each one of these octets, 128, 64, 32, whoops, 32, 16, 8, 4, 2, and 1. You have bit values. Those bit values that you see up there, and if you can't see them because they're too far off over there, I'm going to put them closer to the middle so you can see it. Those bit values right there are the same bit values on every single octet. They do not change. They do not change. When I write those bit values, I use those bit values on the top. So I will put 1, 2, 4, 8, 16, 32, 64, 128, and boom, 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 all the way across. Those are your bit values. As we get later on into a course, you'll understand the importance of those bit values when it comes to subnetting. All right, so those bit values do not change, but the IP address is 8 bits long in each octet. That's why it's called an octet. All right, 8 bits creates a byte, creates a number, a character. All right, and that's why we see, as humans, we see those numbers. But behind the scenes, what you're really looking at, the computer's really looking at, is the binary format of that particular number. It used to be, and I'm going to pick some easy numbers because I just don't want to do any math. All right, 224.240.252. Let's pick that as an address. All right, so, and the only reason I'm doing that because that's the table that I know, and I don't want to do any math. All right, come here, 1, 2, 3. 1, 2, 3, 4, and then 252. 1, 2, 3, 4, 5, 6. That is that IP address looks like that in binary. Obviously, I picked the table, the bit to decimal table, so make it easy. But that's what I'm trying to get at. That's what it's looking at. It's not looking at the decimal that we see. It's looking at the binary bits that are on. So that's why turning things into binary is very important. So you can never go wrong. Because once we get into summarization, we're going to do it in binary format. You'll never go wrong. You'll always get the right answer. So this you need to understand, the format of this particular IP address. That it is 32 bits, but each one of these octets is separated into 8 bits, and that the bit values that it has on top, by turning them on or off, will create that particular number. Okay? So this, ladies and gentlemen, is your IPv4 addresses or address. This is what it looks like. This is the format of it. And we use it so we can assign it to devices so we can communicate with each other. I'll see you in the next video.